Here is FleetIQ workload acceleration. So I have all-reduce job running at 1.4 terabits per second already in the cluster. I'm going to start a second job, an all-to-all job in the same cluster. So there are two cross-rack jobs now running in my cluster, and we can see the effect of this to the throughput of both of these workloads. Because they are cross-rack jobs, there's a lot of contention at the spine layer flows. So the throughput now for each of these workloads is at 770 gigabits per second for the first job and 675 gigabits per second for the second job. The network cards can only have 48 and 38 gigabits per second each for both of these workloads, as opposed to 92 gigabits per second previously. And the reason for that is one-way delays across all the queue pairs right now range anywhere from the fastest one at 4 microsecond all the way up to 40 microsecond to the slowest one-way delay queue pairs. And explicit congestion notification probes are also high now. I'm seeing anywhere up to 15 every second. So the network also realizes there's a lot of contention in the fabric. I'm going to turn on workload acceleration. Because we know one-way delays very accurately, so we know which paths are more congested than others, we are shifting the bytes from more congested paths to uncongested paths. And in doing so, both these workloads now are reaching max throughput they can get in this cluster at 1.4 terabits per second. As you can see, throughput climbing up for both workloads. In addition to this, you can also see the network cards now back to 92 gigabits per second, which is the max we can get out of this cluster. Now, if we look at one-way delays across all queue pairs, they actually converge nicely to a minimal value they can get for both of these workloads running together, 16 microsecond for all the queue pairs. And thanks to this, thanks to workload acceleration achieving this minimal one-way delay across all queue pairs, so the throughput for both the workloads reach the maximum it can get in this cluster. We also see this in the graph below, as ECN marked probes are much less now, only about 1 every second or so. Thanks for joining Clockwork FleetIQ Demo.